Hi, in this project, we will be building a machine learning model that can predict the gender from voice attribute analysis, that is, from our voice dataset. So let's move forward. Now, the first thing that you might ask is what is actually we are doing? So we have a dataset containing attributes related to voice, and through that, we are training a model that can predict if the voice belongs to a female or a male. In this project, even before we start coding, you have to understand about the data. The data is showcasing the physical attributes of voice through which we are making our predictions. Now, the classes for predictions are male and female only. I know some might raise objection, especially at the Pride month or the month of June, but it is what it is. And this is the dataset I had, which had only two categories, that is female and male. So for now, let's just bear with it. So now next we go forward and see the details for the project. Now first part is building a machine learning model to predict if the voice belongs to either of the classes. The second is we build a web app on Django to mount the prediction model. And the last is we deploy the Django project, or I would say the web application, on Heroku through GitHub. So building the machine learning model. We start off with building two machine learning models actually, a SVC and a random forest classifier model, and train both of these models using the voice data points or the dataset. The second part is where we will be building a web application that is on framework Django. Now we mount the model we built in the previous part of the Django project. Now this is the last part where we will be deploying the Django application on Heroku using the connections to GitHub. So now let's hop on to the first part of the project, that is creating the machine learning model. We start off with the first part of the project, that is building a machine learning model. The first code block is for mounting the drive to my Google Colab so that I can now access all the files and folders inside my drive. The next thing you can see that is commented out is pip install mglearn. So we are now installing mglearn, and mglearn is not a pre-installed library, which is pretty clear. So what we are doing this for is because mglearn is a library of helper functions to create figures and datasets. Now we already know that we can use Matplotlib or Seaborn for visualization, and mglearn is a supplement to those libraries. You will see its use case later on in the code itself. Next, we are just importing libraries for creating our machine learning model, as you can see from your Scikit-Learn libraries. So we are importing model selection for using train test split function. We are using accuracy score from the metrics library and SVC and random forest classifier, both of the machine learning models that we are now going to build later on. So starting off, the first thing to do is just call the dataset and look through it. So we are using read CSV to call the dataset that I have named gender voice dataset. And then I'm using the .head function to look at the first 5 data points of my dataset. Now you can see that there are a lot of columns present in this dataset. And you can see that the last column is called label, has male as its values. So this is the target variable, meaning what we are going to predict is this label column itself, where we are going to predict if the voice belongs to a male or a female. So before moving forward, I did tell you about that you have to understand the data first before going forward and doing maybe ED or feature engineering on the data. So I've given a brief uh, description, about the data set and each of the columns. And you can see that I've already specified the target variable, that is label. and have given the values male or female for it. So now categorizing or describing the 20 independent variables that we have, starting with mean frequency. So this is the mean frequency of the voice audio of the person. So we know that for listening, our ears are, or I can say the ear is actually able to categorize or recognize voice that ranges from 20 hertz to 20k hertz. So now you can see that the mean frequency is actually the all the frequencies for a person when he was or she was speaking and has a frequency. So we are taking the mean of those frequencies, and all of that is actually in kilohertz. So if you go forward and look at the first column, so it's giving you the mean, and since these are in kilohertz, so the actual mean value was around 50 to 60, 70, 150, and stuff like that. Now you can see that the second column is SD, telling me the standard deviation of the frequency of the voice audio. So just to make things a little more clear, let me just show you an example of what all of these are. Let's say that the audio was of 3 seconds. So for the first second, the frequency was maybe 55 hertz. Then for the second, the frequency was, let's say, 72 hertz. And for the third second, the frequency was, let's say, 44 hertz. So what this mean frequency is doing is taking the mean of 55, 72, and 44. Similarly, the standard deviation is for these three values. Again, you can see that the mean is taking the median is taking the median frequency of the voice audio. So first it is actually converted to kilohertz, then it is taking the mean, standard deviation, median, first quartile, third quartile, interquartile range. Now, if you're not a statistics person, you won't be understanding much of this. But if you really want to understand about the data, so go and look through first quartile and third quartile, because while I might not include them later on, but it is quite important to understand what quartiles define for a discrete variable. Okay, so next you can see is skew. Now skew and Kurt both are present in my data set. Now what both of them are defining. So skewness refers to a distortion or asymmetry that deviates from the symmetrical bell curve or normal distribution. Now you can see that a normal distribution is like a bell, and dataset having a normal distribution is very well recognized or generalized by the model, because the dataset is defined in a very good way. Skewness basically tells you if more of the dataset is concentrated to the left half or the right half. Okay, and these halves are actually determined by your mean value. So if the dataset is concentrated in the left half, that means that let's say there are 10 data points, then 6 data points have values that are below or less than the mean value. So that is what is determined by skew, and Kurt is for determining kurtosis. That is a statistical measure that defines how heavily the tails of a distribution differ from the tails of a normal distribution. Now, this is something that might be confusing to a lot of people, even to people who have statistics as a subject or might have learned about kurtosis beforehand somewhere. So I would like you to go and understand kurtosis, because an image representation would be much better than just reading about it. So the next is spectral entropy, and frankly I don't even understand what this was, so I've skipped this one. And next is spectral flatness. Now spectral basically determines the ranges of frequencies. Okay. Now entropy and flatness is something that I'm not really understood about, but from the perspective of voice you can say that, let's say taking this as an example itself. Now even in light we have spectrums, right? Ultraviolet rays, infrared rays, and stuff like that. So similarly, in voice also we have spectrals that are defined by certain categories or certain characteristics. And let's say that 55 was categorized as spectrum 2 and 72 was categorized as spectrum 3. So both of them are going to go in spectrum 2 and 3 respectively. So like that, we have our spectral entropy calculated and spectral flatness calculated. Now mode is again simply the mode of the frequency. Since if I just add on and say that for 4th second the frequency was 44 hertz again. So the mode for this data point would be 44. Okay, since 44 has been the most occurrent time. And next is centroid. So that is telling me the frequency centroid. Yeah. So from this point onward, if you want to understand about the data, you have to search about spec crop. So spec crop actually is a function that takes in certain data points about the voice, or I would say about the audio, and extracts even more meaningful information from that audio so that it can be used. And that meaningful information is mean function, min function, max function, mean dom, min dom, df range, and mod index. That is modulation index. So if you have learned about, I would say, voice, audio, or frequencies or signals, then you would know that there's a modulation index that is actually ranges from 0 to 1. Not 0 to 1, but it basically tells that for a modulation of index of 1, there's no upgrade in amplitude of the voice. But if the modulation is less than 1, that means the amplitude has decreased. Again, if you're not understanding this, it is better to search for spectrum and see what all information it gathers and what all information it outputs, and what each of the information, I would say each of the point, that is mean function or maybe mean DOM, actually means. Now moving forward, okay, so I've already also defined the values for skewness, and which value would you prefer or would you keep? So you can see that a value between minus 0.5 to zero point 0.5 is fairly symmetrical, meaning the shape of the data or the normal distribution would be a bell curve itself, meaning that a value between this is a good value and we can use it directly. No need to change the data points or maybe remove the outliers or such. But a value between this means that the data is moderately skewed, which is not really good. And a value of here satisfying this condition means the dataset is highly skewed, and if you directly use the dataset as such to train the model will fare very poorly. So I've already defined a basic description and I've already told you about specprop also. So this function returns a list of statistical properties of a frequency spectrum which have been defined above. That is have been defined above. Okay. And for more information, you can just visit this link itself and see for yourself what specprop does. Now we started with EDA, that is exploratory data analysis, where we are using the is null function and dot sum to gather if there is any null value, and if there is, then the frequency of it for each of the columns. So we can say that the data set is pretty clean in terms of null values, at least, because there's no null value present. Now I'm using the okay now I'm using the describe function, which is again giving me the counts, that is telling me that there are 3168 data points in our data set, and again the standard deviation for each of the columns, the max value, the minimum value. So you can see that for all the integral types or float type data points or data columns, we have the minimum, the maximum, averages of it. Now, again, if you're not a statistical person, you might not be able to understand why I'm using this and what I'm inferring from this. But one thing I would like to notice you, one thing I would like you to notice is that just check out the minimum and max for each of the columns. What happens sometimes is that for one column, the range meaning minimum to max, might be 1 to 10, and for another column, it might be 0.1 to 10,000. Now, both of these ranges are very different, and while setting the data and then giving this data to the model to train, the model might not be able to generalize well, meaning the model might not be able to find particular patterns because the ranges were too far apart. So for that, we do standardization, and but to see if we have to use standardization or not, it is preferable to first see if there are columns which have ranges that are too far apart. So for that, I am using describe. So now I have given some pointer that is telling me, you can see for column like Q25 and maxdom that we have very large ranges as compared to other columns. So for this, just like I told you, we have standardization. Okay, I have not included normalization. So in normalization, what we do is, rather than just comparing two columns for their ranges and setting the ranges in a comparable manner, we just change the range for one column looking at the other column. Okay, so I've not included standardization for this project because we are actually not going to use Q25. The next thing that we are doing is using a heat map that is present in our Seaborn library to build a correlation graph. Now, correlation is basically telling you about, for two columns, let's say A and B, how much related they are to each other or how much dependent they are to each other. That would mean that, say, for column A, I'm increasing each and every value in column A by 3. So how much change would it occur for column B? Would it increase? Would it decrease? So that is what correlation basically tells you about. So you can see that for each and every column, there's a mapping for each and every column itself. And you can see some of the values here ranging from 1 to -1. Now correlation actually ranges from 1 to -1. A value of -1 telling me that column A is inversely related to column B. Meaning if I am increasing the value by 1 for column A, so nearly there would be a decrease of -1, there would be a decrease of 1 in column B. So why I'm actually taking this out is to understand which of the columns are highly dependent on each other. Okay, and then I'm going to remove one of the columns, because while you input this data, column A and column B are highly correlated. So what happens? Column B is not able to provide much information that is too different from column A, and the model just thinks that, yeah, column B is again telling me what column A is telling, and this doesn't really help the model in understanding the patterns inside the data, and in turn actually increases the dimensionality of the data itself. Say for column, 5 columns, there are 2 columns that are not giving me any type of information. So it would be better to use 3 columns only, and it is also reducing the dimensionality, meaning the model would be training in less time also. So for this, we are using our Seaborn library, and you can see that the first parameter is gen.call. Basically, my gen variable is of pandas having the dataset, and .core is the function that is determining or that is providing all the information for correlation. And that is the first parameter. The next is just to color and the width of each boxes for the correlation. Now you can see that there's 1111, there's a value of 0.98. So it determines on the basis that what you might consider to be very high. In my opinion, I would say a value of 0.91 is high, but a value of 0.59 or 47 is not. So I would let these columns stay, but for values of 0.91, I would remove one of the columns. So let's say for this example, Q of 25 having a correlation of 0.91 with centroid. So I would be removing either centroid or either Q25. Similarly, I'm looking at all the other boxes or values which have high values, like even minus 0.87 is telling me that Q25 column is highly inversely correlated to IQR column. So I would be removing either of those columns. So with that in mind, I have already segregated which columns to remove, and though I have not set those columns here or written them down, you would see that later on I'm removing some of the columns according to this graph itself. So next thing what I'm doing is just looking for my label column and seeing if the label column has imbalance in classes or not. So imbalance basically means that, let's say there are two classes, class A and class B, but class A has only 10 instances while class B have 900. So this is what we call imbalance in classes. But you can see that from the histogram, you can see that the count for both the classes are equal or nearly equal. So there is no imbalance in classes also, which is good for us. So next thing we are doing is finding out for each of the columns if that column is going to help us in differentiating if the voice is of a male or of a female. Now you can see that we are using the mglearn and its function cm3 and defining or providing it with parameters or arguments as 0 and 2 and building a histogram. So you can see that from all the histograms that have been defined here, yeah, let's start with the first column. So its histogram is defined here, and the y-axis is for the frequency and the x-axis for feature magnitude, meaning the max and min values for each of the values inside my mean frequency. You can see that the male, that is determined by blue, and female determined by green, are converging for a lot of data points and are differentiated for very less. So mean frequency is not helping us much in determining the male and female classes. The next is standard deviation, and you can see that the classes are pretty much defined. They have intersection for some data points, but you can see that for much of the data points, it is able to differentiate. Similarly, you can see for median, it is not able to. Again, for Q25, it is able to. Q75, it converges for a lot of data points, so no. IQR is able to differentiate. Skew is not. Kurt is totally not. and you can see the spectral entropy is able to differentiate. SFM maybe not. Mode for some part, yeah, it is able to. Centroid again, maybe no. Mean function is able to do that pretty well because there is a very small point of conversion. And similarly for the rest of it, you can see. So I've already defined also that from the graph you can see which of the columns are able to define male and female separately. So taking all of that in consideration, now I'm dropping some of the columns which you can see, and the columns that now I'm going to use for training are these. So I'm not dropping the Q25, and you can see that even though it had high covariance value, since it is able to differentiate male and female pretty well, I'm not dropping this Q25 column from my data set. I'm just segregating the independent and dependent variables. And now I've used the train test split function to set the train size as 80% of the total data and test size as 20% of the total data. I'm using the SVC, that is support vector machine, to fit, and it is giving me an accuracy of 0.73, that is 73% on test set, and on training a value of 72%. Now next I'm using the random forest classifier, and even with base parameters I'm getting accuracy on training of 100% and an accuracy of test of 98%. Since both of these accuracies are pretty close, that means the model has not overfit and has generalized well on the dataset, giving me a very high accuracy. So with that, we just save the model, that is the last part of this sub part of the project. With that, I've saved the model, and now this saved model is what I'm going to use in my Django web application itself. So with this, the first part has been finished, and now we can move to the second part, that is building our web application using Django framework. Now, this is the second part of the project where we are building the web application that is using Django framework. But before we actually move on to the code, there are some steps to be followed so that you can set up the Django application itself. So first, just set up a directory where you will be keeping the code. Okay. So for that, I've just built myself a voice gender prediction directory where I'm just keeping the code. Second, in your terminal, or maybe if you have a IDE like I have, open that up, set up the project and build an environment. So you have to build a new environment for this project such that in that environment all the packages and dependencies are stored and used by the Django web application. So what I did was, if you're using PyCharm, just go to the settings, and in your settings just go to the project interpreter, and you can see that a already instantiated environment is voice gender prediction. Okay, and in that environment all the dependencies are present that you can see here. So next thing, it is not like you have to install each and every dependency or package one by one. What you can do is just go inside your voice gender prediction, okay, then go inside my site if you have already built a Django project, and then run the command pip install requirements.txt. If you run this command, then all the dependencies that are stored in my requirements.txt will be downloaded and then installed inside your environment itself. So if you have already just specified a directory, not a Django project, then first you have to build a Django project. For that, what you can do is just run the command Django admin start project and then name of the project. Since for my project I have named my site, so you can see my site project was instantiated. Now you can see that once you run this code, okay, you will see a my site being present, and inside that you would see another my site where settings and VSGI files are present. Then what you do is go inside your my site directory. So you would be first in your first directory, project directory only. Then you go inside your Django project directory. Okay, once you do that, what you have to do is run the command python manage.py start app and then the name of the app. Since I named the app polls, so you can see that a polls app will be generated and some of the files would be present here. So the good thing about Django is that it already builds you a base app on which you can modify, extend, update, create something new, and store it on the base app itself. So with that, what we have to do is just make changes in some of the files and the app would be running with your web application developed but locally. So you can see that all of these files are already present, and what you have to do is go into the views. So for views, only one views.py is present for one app. So you can see that in polls app only one view is present, and this is where all the backend work, or I would say the backend implementation occurs. Meaning, if you're handling the data, if you're modifying the data in the backend, storing the data through the backend, sending the data from the backend to the front end, all of that happens in views.py. You can see I have already imported some of the functions from Django that are render and redirect. So render function basically renders files or templates, I would say, where templates are HTML files. Okay, you can see that there's a template folder also which has main page.html, and if you would see the first function that is named voice, in the last you can see there's a render function that I'm returning with main page.html, telling that for this function, if this function runs, you have to render the main page.html. And if you're sending some information from backend to front end, you can do that through context. And by context, I mean this. This thing is called context, where you're defining your information in the form of dictionary. So let me start from above. Okay. And see, the first thing that we are doing is taking the data from my front end and storing them in variables that I've defined here. Okay, so you can see there's a lot of variables that I've defined. Then I'm sending all of these variables into a function named finder. So if we go to the finder function, you can see that the finder function is taking all of these variables or all of these parameters and then creating a data frame out of it. So you can see that empty data frame was created, then it was filled with the values. Now I'm using this data frame as my data to be input into the predict function of my model so that I'm able to predict the label class if it is male or female. So you can see that I'm storing that in res and then returning the res variable. So the data was sent to the finder function where prediction occurred, and the data, or I would say the result, was stored in res variable, sent back to the first function named voice, and you can see that I stored that in results, and that result is what I'm sending to my main page.html as context. So this might be a little confusing to understand. So I would run the program first and you would be able to see how it is happening. but that would be in the third part where I'm actually already have deployed the code or the web application to Heroku. So this is where all of the data is being handled, sent back, sent in from the web application to the backend. I would say from the front end to the backend and from the backend to the front end again. So this is what Django is capable of. And before we move forward again to I would say to the next topic, I would like to showcase the settings.py file. Now, if you have just built a Django project, meaning just the base has been built or instantiated, you haven't changed anything, you would see that the is equal to true and there's nothing written in allowed host. Now, since I've already changed the code so that it can be run on production, I have made changes that is from true to false, and then in allowed host, I set up some URL. So you can even see that the security warning is already telling you that don't run with debug turned on in production. Another thing is that Django is itself capable of handling security risks. All of these middleware that you see here are middlewares that are capable of handling vulnerabilities that you might maybe have to set up on your own if you were on some other programming language like PHP or such. So that is one plus point also. You can see that clickjacking, that is X framework option middleware is present, security middleware is present, sessions is present. So you don't have to manually set up things in Django. It has already been set up for you, and you just have to write basic functions that will help in rendering of pages. Again, you can just go, okay, this is where you are setting up your database that is going to be attached with your web application, and it already gives you an option of SQLite 3, so that Django is already capable of using SQLite 3 within itself. You don't have to download anything else for this. But if you're using a database like Postgres or such, then you have to specify it inside here. Next, you would see about, yeah. So again, this line again won't be present if you have just instantiated your Django project. So this line is basically telling you about that all of the static files that you can see, the CSS files, JavaScript files, images, all of them are actually have to be amalgamated, I would say, to one folder, that is static files, when you have shifted your code to production, so that the server is able to understand that each and every file is not diversified into different places inside the code, but have been present in just one place, and it would search at that one place only. So with this, I would like to conclude the second part, that is about the Django framework and web application that we have built. And last thing that I would like to tell you about is, if I run the command python manage.py run server, if I run this command, so your code would start, but would be uploaded, I would say, locally, or so would start running locally. And if you click on this, the link that is provided to you here, you can see, so you can see that if I type voice here, so see the page has been rendered, that is a form, and you just have to give in the values here, okay, and then click on submission. After that, the value or the, yeah, let me just directly put in, yeah, I just would put in anything, so don't mind the name and any other values that I have set up beforehand. Yeah, so and there are a lot of values. Yeah, finally the form has been filled. If I just click on confirm submission, so you would see that, yeah, so you would see that the voice is of a female. So it has predicted. So with this, I would just complete the second part. This is the third part of the course where we will be deploying our web application on Heroku. Before we start with Heroku, we have to use some files which are like commands for Heroku to understand. So let's start with the runtime.txt and proc file. So what you can see is the first part, that is runtime.txt, having written Python dash the version of it. Now understand this, that Heroku doesn't use or doesn't have setup for each and every version of Python. So it has predetermined some versions like 3.7.10, 3.6.13, and so on. So we have to set that up in our runtime.txt for server on Heroku to understand that, yeah, this version of Python has to be used. Now, the next thing you can see is the proc file. Proc file is a mechanism for declaring what commands are to be run by your application in Heroku platform. The commands that are specified in the last part, like python manage.py run server or python manage.py migrate, these commands are executed in Heroku server using the proc file. Now, there are even more commands that I would say, like python manage.py collect static, that is the command that is telling the web application to store all of its static files into the static files directory that I have defined in settings.py. So there are even more commands that can be run or that are ought to be run before the setup or before the start of using the web application. So all of that has been handled by Gunicorn using the mysite.wsgi file that was inside your mysite directory with the settings.py file. So with this, we have set up the files that are required by Heroku before we can push this code to production. The last thing is to set the requirements.txt file, which can be done by the command pip freeze requirements.txt. So with this, we can get all the dependencies stored in the text, that is requirement.txt file. So now if we move forward to Heroku, so you can see that this is my dashboard. Okay, so if you go forward and look at the top right, you can see there's a new button which has create new app. So you can click on here and generate a new app. Since I've already built an app for this project, which is named voice prediction, I would be using this only. Now, lastly, once you have built the app, you go inside the app and you click on open app. So here you would see a link that is present. Okay, so just copy that link. For now, just ignore this part. Just copy that link and in your settings.py file. Now I've already set this up in GitHub also. So I've built a repository and uploaded the code inside that repository. So you can see that this voice gender is the name of the repository, and in the master branch, all of my files are present. Okay, so what you can do is just go in my site, go to the settings, and here set this up. Whatever you copied, just paste this here and remove the HTTP part and slashes. So what this is doing is telling the web application that this DNS can be used to host this code onto a server. So once we have done that, we have finalized and made all the changes that were required inside the web application. Now we start off with deployment or going to production. So you can just first go back to your app, okay, and then inside your app go to settings. Now in settings you would see a build pack. So you add build pack and inside that select Python and then save changes. I've already done that. So you can see that Heroku/Python, a build pack has already been defined for this app itself. Once this is also done, you go to your deploy. Now inside deploy, they are given three options, that is deployment method, having Heroku, GitHub, and container registry. So we will be using GitHub option. So once you click on this, it would ask you to enter your credentials and log in into GitHub. Once you do that, this app will now use your account of GitHub and ask you to connect any one of the repositories to this app on Heroku. So you would see a connect option here. Now, since I've already connected, you can see a disconnect option. So once you click on connect option, what it would do is it would ask you the name of the repository, and then it would, once you click on the required repository, it would connect the repository to this app, and you would see the name like your account name slash the repo name. And then, so next we go on to the manual deploys. Now manual deploy has given you the option to select one of the branches. Since the master branch has the code inside my repo, we will be selecting master and then click on deploy. Now once you click on deploy, this is the point where the server has now started and the Heroku platform is setting up that server so that we can just push the code and use the web application on a server or on deployment itself. So you can see that it has now added the build pack and it has now detected the app and using the Python version 3.7.10 that I had specified in runtime.txt. Yeah. Next, what it is doing is collecting all the dependencies that are required to run this code. And once it's do that, it runs the python manager.py collect static, which I told you about, that it stores all the static files that are diversified inside the code and store them in one point, that is static files directory. Then it compresses the files a little so that it can be inserted into the slug. Lastly, it would show if there's no error, then it would show you that yeah, we have released, and this is the link for which was just now showing. This is the link for your web application. Now you can click on, yeah, wait a minute. You can just click on view, and then it would set up your app and web application would be deployed. Now, since for the home URL, I didn't set any page, so no page is being rendered. Once I type voice, so you can see that, yeah, the page has been rendered now. So once you input the form or you set up the, I would say you fill up the form and then click on submission, then it would give you the prediction like it did in the last part. So with this, we are ending the third part and altogether the project that is predicting gender through voice analysis or voice dataset.